In this video, I'm going to take you through power in an AC circuit. A recap from our DC circuits, power is equal to the total current times the total voltage. In an AC circuit, you realize that we have reactance and we have resistance. So we are going to have two components of power, a power due to reactance and a power due to resistance. And these two makes the power in an AC circuit different from power in a DC circuit. In all, there are three kinds of power in an AC circuit. So three kinds of power in an AC circuit, and they are: you have the apparent power, and it's represented as S. So when we say apparent power in an AC circuit, apparent power represent the total power in our AC circuit. So our total power, the combined power, or the total, mean everything in our AC circuit is what we call the apparent power, represented as S, and the unit is volts amperes. So we are going to have VA. So when you see VA is the total power in our AC circuit, represented as S. The second type of power we have is what we call the active power. The active power. Active power is what we call the resistive power or the true power in our circuit. So true power. So when we say power, or when you are dealing with AC circuit and you see the word power, then they are referring to the active power. If not, they will specify. So active power or true power has the units being what? Watts. So you can also call it the true power or the actual power. Actual power. Some will say the raw power or just simply power. The third type of power we are going to talk about is what we call the reactive power. Initially, I told you that we have reactance and we have resistance in an AC circuit. The power contribution by the reactance is what we call the reactive power, and it's represented as what? Q. The unit of this reactive power is what we call the volts amperes reactive, indicating that it is a reactive component of the volt ampere, which is the total power. It is VAR, that is the unit of a reactive power. So when you see Q, it's a reactive power. When you see the true power, which is also represented as P, then our total power as S. Now, let's see some equations relating to these three kinds of power. So the total power S is always equal to our total current times the total voltage. I told you that the apparent power is the total power and is equal to the total voltage in a circuit times the total current. This apparent power will have two components. The component which is in the same phase with the current, then the components. So here we are not dealing with current, but I want to show you that the true power P is the direct current power we know, so we always place it in position of the current. So here is our Q and this is the S. So the S has two components, a reactive component. You realize that in the phase diagram of our VRL and the RC circuits, the reactive component always lies on the y-axis. So the reactive power Q is here, then the total power is lagging, so it's leading the true power by a phase difference of what, pi of theta. So this is the phasor diagram for the three kinds of power we are talking about. Now let's see this theta here. When we take cosine of it, then we get what we call the power factor. So power factor is how this true power is deviating from the total power. So cos of the phase difference between the true power and the total power is what we call the power factor. Now let's see from this diagram. Here is also our Q. You can say that S squared will be equal to Q squared plus what, P squared, right? Apparent power squared is equal to active power squared plus the reactive power squared. Now, I told you that cos theta here is equal to what? Power factor. And you know that P being the horizontal component is equal to cos theta multiplying what, S. So S cos theta will give us P, S sin theta will give us Q. But cos theta, as I said, is the power factor. So meaning that our true power P is always equal to the total power times the power factor. The apparent power times the power factor, right? So once we get this done, then let's see. The reactive component R is always equal to S sine what, theta. And this one is the total apparent power times what, sine theta. The sine theta is not having a name here. It's only the cos theta which is of interest, called the power factor in power. So these are some basic formula you are going to see when you are dealing with power in an AC circuit. This is the end of this video. Thank you for being with me. Please subscribe to support. Don't forget to like and share.